This podcast is brought to you by LMU Munich.
All right, hello again. I hope you had an enjoyable coffee break. Please welcome our next speaker, Randall Hunt, who will give us a talk about serverless.
Hi everybody, thank you so much for coming to my talk. There are a lot of other talks happening and workshops and things happening, so it means a lot that you guys took the time to come here. I want to thank the conference organizers for putting on what has so far been, and it's only the third talk of the day, so not 100% sure yet, but it's been pretty great so far. My name is Randall Hunt, and I'm a software engineer at Amazon Web Services. I live in Los Angeles, California. It's terrible, don't go there. I'm wondering, okay, this is going to be really bad. Ich muss mein Deutsch üben, also müssen Sie mehr Demo oder mehr sprechen? Mehr Deutsch sprechen? Ich glaube, dass ich kann fast kein Deutsch sprechen. Mein Deutsch ist sehr schlecht, aber ich werde probieren ein bisschen. Yeah. Do you guys want more demos or do you want more talking? Demos. Okay, cool. We can do that. So the first thing that I'm wondering, being a millennial who just celebrated my birthday, can we take a selfie? Thank you. This is going to be great. Cool. Thank you. So we're just going to go like this, like da-da-da-da. We'll take it again. Okay, so that's going to come into play a little bit later. So who am I, and why should you listen to me? The answer to the second question is that you should not listen to me. I know nothing about anything. I am literally just bullshitting all of you. It's completely fake. But I have some experience working with some larger scale systems, and I've been fortunate enough to work for a couple of really cool companies. The coolest so far was SpaceX, and Amazon Web Services is where I am now. It's where I was before. SpaceX is an amazing company. Has anybody heard of SpaceX? Okay, they do really, really awesome work. And I worked as a flight software engineer there. And I was there when we landed our first rocket, and it was just like a super, super cool opportunity. The unfortunate downside of SpaceX is that I'm pretty sure I never left the office for a year straight. I slept, ate, did everything there. Amazon is much more enjoyable with the work-life balance. Nobody laughed. So if you guys are interested in serverless hot takes and things like that, you're welcome to follow me on Twitter. This is my email, randhunt@amazon.com. You can ask me about anything related to AWS at any point in time. I primarily work in Python, but I'll occasionally do C++ or Java if you yell at me enough. But JavaScript is terrible. JavaScript is basically my psychosis. So if you email me a JavaScript problem, I'm just going to forward you to spam. Okay, so what I want to talk about today, we have this new paradigm that's kind of taken hold of our industry, which is serverless. And I'm from New York originally, so I speak English and I speak it quickly. So if I need to go slower or something, let me know. I just gave a presentation in Korea, and the translator was really pissed off at me. So there are a lot of idioms that don't translate. So what I want to talk about with serverless is the idea of functions as a service, and then using API gateways to front those functions as a service. And I'm going to talk primarily about Amazon Web Services because that's what they pay me to do. But there are plenty of other providers that have similar offerings. So Azure has an offering, IBM has an offering, Google has an offering, and I would encourage you to actually go check those out. I'm not like a corporate shill. I'm not going to sit here and tell you that ours is the best. It is, but I'm not going to tell you that you have to use it and the others suck, because they don't. There's a lot of really exciting work happening in this field, in this paradigm, and it's worth your time to go and look at all of it. So what I want to talk about is when you should use serverless. And right now, I'm very confident that about 70% of the time, it's going to be the right answer. And when you should not use it is about 10%, and then I'm just really bad at math. So the other 20%, 10%, however the math works, is kind of difficult. I don't know what the right answers are, and I'm not sure that anybody does yet, just because it's a fairly new field. So when you experiment with these things, you have the opportunity to contribute back to the community and to take your learnings and put them into the greater field of knowledge. There's a serverless Slack channel, there are blog posts, forums, all of that fun stuff. So I would strongly encourage you, as you experiment with this sort of stuff, to go out and look at it. So what the hell is it? Serverless applications are basically taking the insanity that has become managing servers over the past few years and making that go away. So one of AWS's core competencies is removing the undifferentiated heavy lifting from your applications. And I have had a career of DevOps work. I've been paged at 1 a.m. Hey, Elon wants to play with the rocket. Like, how do we enable that right now? And so I have to go in and I have to clear out a bunch of log files and do all this other crap so that somebody can SSH into a rocket and blow up a $60 million machine. And I don't like doing that. I don't like being paged. I don't like managing patch levels. I don't like doing any of this nonsense. And for a long time, Heroku kind of abstracted that away for me. But then there are other options too. So let's just take a quick look, right? Like, let's go back and think about how things started. We had these physical servers in data centers. That's how everything sort of got started with the internet. You had 1968, I guess you could say, you had ARPANET, right? And you had one computer talking to another computer over TCP. I put that in quotes because people hadn't yet agreed on what the right way to send the messages were. So sometimes you just got random stuff, and you were like, "What the heck is this?" Because Stanford was like, "We know better," and they didn't. So then we move into virtual servers and data centers. And virtual servers take advantage of like Zen or KVM or any of these virtualization paradigms, and they take advantage of processors that are designed to do virtualization. So processors these days, there's very little overhead of running virtualized instructions versus running regular instructions. And so virtualization, you don't really take a performance hit at all. I mean, maybe some tiny little bit, but not like what you used to. And so you get these virtual servers in these data centers. And then we have the cloud, TM. TM is a trademark, by the way. And I applied for the cloud trademark, and I didn't get it. So virtual servers, what it means is you're basically buying and renting time on these servers. So you pay by hour or you pay by minute or whatever pricing scheme Cloud Company 2.0 comes up with. Like, that's what you're paying for. You're renting this compute time, this storage time, and this RAM time. And each progressive step of this, everything got better. We were able to do more stuff. We were able to build better things. And our agility improved. Our ability to go from nothing to production, that time decreased. And you got higher utilization. You were able to trade your capital expenditure for your operational expenditure. And I can see everybody's eyes glazing over. So let's skip through. So there's still limitations. So that's a really pretty slide. I didn't know those animations were there. So now we have serverless. And serverless says, rather than dealing with servers, and obviously, I hate the word serverless sometimes because there are obviously still servers there. You're just not managing them. So what it is all of these responsibilities of provisioning, utilization, cost optimization, scaling, operations and management go away, and you just have an entirely different set of problems to deal with. And when you're owning servers, you have to deal with all this stuff, right? You are constantly fighting to maintain this stuff. If you put the operational, I'm trying to think of like a onus on other people, the benefit to your business is very large because it allows you to focus on the things that differentiate your business versus the things that differentiate your individual engineers who are on call that night. So this is what a typical serverless application looks like. You have mobile apps, websites, various other things coming in through the internet, It's fronted by CloudFront. CloudFront is basically a content distribution network. And then it goes into this thing called API Gateway. An API Gateway can go out and talk to Lambda functions, and I'll cover what these are in a little bit. Or it can go and talk out to your plain EC2 servers or other stuff. Or you can even front other things that are off of AWS. And you can talk to any other service. It's pretty full-featured. And a lot of common use cases for this are web applications, API backends. People have started using it for EMR, for data processing, for batch compute jobs. I have 5,000 selfies because I'm a millennial, and I process all my selfies and detect labels and run them through TensorFlow, all in Lambda. Chatbots are another really common use case. So I have a chatbot because, does anybody have parents? I have parents. Most humans have had the opportunity to have parents. And they ask a lot of questions about your health and well-being. So my mother generates, I would say, 10,000 requests per second, typically in JSON format, about my health and well-being. And what I try and do is I try and respond to those in a realistic way without her realizing that it's a robot. And I'll demonstrate that a little bit later. And it's all in Python, and it's only maybe 40 lines of code, and I'm able to respond to a couple different invocation types. So my mother could curl an endpoint, or my grandpa could curl an endpoint, and they could say, oh, this is Randall's current location at this timestamp. Or, maybe they don't like using curl. Maybe they prefer, invoking a Lambda function directly with their IAM credentials. Obviously, they're not that tech savvy, so that maybe they don't like curl, maybe they don't like IAM, so then they could have an Alexa skill. And it's the exact same code running everywhere. It's the exact same function as a service. You're just applying different transforms on the output. And that's a very powerful paradigm. And then there are other skills you can use. So does anybody have to, I know it's Germany, so do any of you have to deal with compliance? Yeah, HIPAA, PCI, data regency stuff. So I gave a talk at reInvent last year about how to build your own compliance engine in AWS Lambda. And it was a really crappy talk, so don't go watch it. How about a demo? Yeah, okay. I talked for long enough, right? How am I doing on time? 12 minutes. Oh, dear. We're definitely not going to have time for our demo. This is not the right file. This is probably the right file. Nope. PyCharm is a great editor, by the way. I strongly recommend it. I'm a big fan. I don't use it that often, but I've been told that I need to stop using Vim because people can't follow what I'm doing. No. I think we're going to have to use Vim. Okay, cool. So we have this code, right? This is kind of like my web app, or this is the core function. It's only one function that I'm running, and it's just get my location from Foursquare. And then this isn't the real code that I run because people are malicious and they, throttle. They try and DDoS me and things. And even though I don't pay my own AWS bill, I don't want to charge AWS, a couple terabytes a week. But you guys are welcome to try. And then I have this little handler, and all it does is it just launches one of those different endpoints depending on my input. So what I do, if I go over here to the console, oh, we're already in the Lambda console, sorry. What is it? Where am I? Yeah, that's it. So I have this little bot, right? This where bot. And it gets invoked sometimes. And basically, I confront that with API Gateway. I'm going to go really, really fast now. I'm sorry, I don't have a lot of time. So if you miss something or if you're curious about something, you're more than welcome to email me later, and we'll cover it then. So basically, I have this API Gateway that I've deployed, which is my website. And if I invoke this Lambda function just from here, I send in some basic nonsense, I'll get this response, right? Like, this is my current location. This is where I am. But with API Gateway, I'm able to take that same function with no code changes, and I'm able to curl an endpoint So for those of you who couldn't see, those are just the headers and everything. And I'm able to see, what exactly is happening. And to prove to you that it's working, I'll go ahead and check in somewhere else. And while I'm doing that, I'm going to continue with my presentation by going to this. Lots of different things happening at once now. And then we will go back here, and we'll play from this slide. I'm going to go here and check in. And then just to prove that it happens like instantaneously, I'm now at this place, whatever that means. So cool. So what is AWS Lambda? AWS Lambda is event-driven, continuous scaling, pay by usage. So if you think about the different compute offerings that we have, you have EC2 is like your VPS, your virtual private server. ECS is like your containerization. Lambda is like a function. The abstraction level of Lambda is the runtime. The abstraction level of EC2 is the hardware, and the abstraction level of ECS, something like a container, Dockers like that, is going to be the OS. So with each one of, I'm sorry, I'm speaking really quickly. I'm just going to try and get through it all. So you have these different event sources you call out. This has the word node in it. That's a terrible language, don't use it. And then you run your own code. You pay in terms of gigabyte seconds. So how do you guys pay? I know Germany is really big on renewable energy, but how do you guys pay for things here? Is it like kilowatt hours, or when you pay for electricity? So kilowatt hours. So a gigabyte second is like a kilowatt hour. It's partially analogous to that. How am I doing on time? 3 minutes? Okay. Okay. So we have these. We can author these functions, and we can deploy them, and then we can invoke them in various different ways from various different event sources. Now, API Gateway allows you to take a bunch of different functions or a bunch of different underlying services and unify them in one place and deploy them and manage them in one place. Has anybody used Swagger before? Swagger is a great language for deploying your APIs and maintaining your APIs and building documentation and SDKs for your APIs. So you can import your Swagger document into API Gateway, and it will build out everything for you. It has throttling, it has authentication, it has all of the different things that you would expect to have. It has custom authorizers, so you can call out to various things that you need to authorize stuff. It has throttling protection, DDoS protection. Okay, so there are a couple different design patterns with serverless applications. The first is the monolithic application. That's the primary one that I use when I'm developing. And the reason that I use that is it's very easy to take an existing application like a WSGI container, Flask, or Django, something like that, and you can go and you can say, hey, I don't care about building out individual endpoints. I just want you to take every input that comes in through my API gateway and send it to this monolithic application, which is essentially a WSGI container that's executing on Lambda. And the reason I do that, that's where I start, is that's how all of the code that I've ever written is already written. But what happens is eventually something goes wrong. Eventually my mother generates 10,001 requests per second, and I'm no longer able to keep up with the load. So I have to modify it, and I have to change something. So when that happens, what I do is I split out the endpoint that's failing. I split out the portion that's failing, and I go and I say, hey, let me turn this into a microservice. I'm skipping a lot of slides because I don't have a ton of time, I'm sorry. So here are the pros of microservices. It's much easier to debug. It's much easier to develop quickly until it reaches a certain size, and then everything goes to shit. So the cons are you have the single handler, the single invoke point, and it's harder to be resilient. If one thing goes wrong, everything goes wrong. These are the benefits of microservices. Skipping a lot of slides again, I'm sorry. Okay. Come on. I'm sorry. I want to be able to get to more demos. So the benefits of microservices are, forget the slides. The benefits of microservices are that you are able to take these, what do you guys think of microservices? Do you think auth is a microservice? What? Do you think authentication is a microservice? Okay, authentication is not a microservice, it is a macro service. Login is a microservice. Logout is a microservice. Recover password is a microservice. Authentication encapsulates a whole suite of things that is a large component of your application. So when you talk about microservices, you have to think in functional components. What are the things that individual developers are comfortable being responsible for and deploying out of sync with the rest of the team. Like, can this component be deployed without affecting anything else? And when you get to that point, when you build all of these different microservices applications, you run into a lot of issues with deployment, debugging, all of it. It becomes very complex and hard to manage. So we built this thing called SAM, which is just a CloudFormation transform. This is what a normal CloudFormation template looks like. This is how you would normally deploy your applications. This is what a SAM template looks like. That's bad, this is good, that's bad, this is good. Okay? All these slides will be made available, I'm so sorry. But serverless is great, everything is wonderful, blah, 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 blah. There is a time when you don't want to use serverless, right? So let's think about our traditional deployment. We have an auto-scaling group, an elastic load balancer, and like 2 T2 nanos. And that can serve on the order of like 200 transactions per second, right? And you're running that for 30 days out of the month, 24/7, and it's going to cost you about $12, not including bandwidth. So you're paying for the time where the server's not working, you're paying for the minutes it takes to scale up or scale down, and it's actually quite easy to debug, right? Because the tool chains for all of these different, Sentry exists, New Relic exists. All of these platforms for dealing with traditional servers have been around for a long time, and we're very familiar with it, and that's my remote. Now, when you get to functions as a service, if you're running that same workload on functions as a service, it's very possible it's more expensive. Despite the very low cost of a gigabyte second of billing, you're going to potentially pay more. So you've got to kind of do the consideration, is the increased agility and ability to deal with stuff worth it for me? And the answer sometimes is no. So I have things that I still run not in a serverless environment. Now, those costs are only going to decrease, and the tool chain is only going to get better. This trend is only, it's not like NoSQL, it's going to stick around, because it's really important. Sorry, that's a bad joke. And it only takes milliseconds to scale, and you can scale to huge amounts. So there's this project called PyRen, for instance, and what it does is it allows you to take a regular function call in Python, and you can go out and you can say, hey, regular function call, I want you to run on Lambda instead, and I want you to run at whatever capacity you can possibly run at. So people are getting, a couple hundred gigabits per second of throughput to S3 through Lambda. People are able to get a couple hundred teraflops of compute capacity through Lambda, and it costs them almost nothing. So there are tons of advantages to this new paradigm, but take the time to do the cost analysis, because it's not always going to be the right thing. There are a bunch of really cool frameworks. Forget everything except for Zappa. Chalice is the one that we made, so I have to talk about it. It's actually not bad. I like it. It does some cool stuff. Zappa is amazing. There's this person named Mizerlu who runs gun.io, and it is just one of the coolest Python frameworks I've ever had the pleasure of working with. If you have a Django app, if you have a Flask app, if you have a Tornado app, whatever, you can take that and literally make no code changes, deploy that app on Lambda. So if you're like me and your personal website only gets one hit a year, it's much cheaper to run it on Lambda than to run it on Elastic Beanstalk and keep those servers around all the time. Whew. So serverless is growing, people love it. There are a lot of different projects, there's a lot of different things happening, it's getting big all the time. These are a bunch of customers. There's this company called FINRA, which processes financial interactions. 23andMe is doing genetics analysis. Zillow is doing real-time estimates of housing. Airbnb is doing it. Everybody's building real stuff on this. It's like a real thing. It's not fake. And SAM is really cool. And let's get back to the demo, because I've only got 2 more minutes. No. What's going on? Okay, I'm going to execute the demo from the mirrored screens. So you saw the thing that I had earlier. Come on. This is awful. How do I... I have to hold my mouth, right? Okay, cool. Okay, so what I'm going to do is show you very quickly Lex, and this is all written in Python. Like I said before, you saw my my little web thing. I have this bot, whereas Randall, that my mother uses occasionally, and I put in these couple sample utterances like, hey, where are you? And I can say hey, where the hell are you? and it'll respond. But there are also channels that I can go out to without having to write any of the code, and I can be like, hey, I can go to Messenger bot, and I didn't have to write any code to connect with this. I just literally told it to do it. Where is Randall? And then I can even do things through voice interfaces. Oh look, somebody wished me happy birthday. This never works.
Ask me where I am.
Where are you?
Randall was locked at Leslie's Maximilian University. ISTW 900.
Okay, cool. So all of this stuff is done with thank you. All of this stuff is done with 2 lines of code. It's really, really powerful. I strongly recommend, and it's all in Python. All of these GitHub repos are open. You can go to github.com/randman. You can look at it. You can play with it. You're more than welcome to email me any questions. Haben Sie Frage? Yeah.
I think we have time for a few quick questions.
That was a lot. I'm sorry. Yes.
Okay. So if you have a function that has a very expensive initialization,
Yes.
How do you know where's the sweet spot to move to serverless or stay?
So the question was, if you have a function that has a very expensive initialization, how do you know when you move to EC2? When you say initialization, is it initialization to the actual point of where you start executing, or is it the initialization to the point of you have to download a bunch of data for a machine learning model, for instance?
Or you have
Yeah.
to import very expensive libraries that they go.
Right. So it's the initialization time is the hard part. And my response to that is, if you can get it from S3 in less than 10 seconds, regardless of how large it is, the Lambda function will most likely perform better, and it will be more parallelizable than if you were running it on EC2. So that's my rule right now. That rule is not static. It will change over time as different factors improve. So 10 seconds is my current rule. And I have an example of using machine learning model within Lambda, and also FFmpeg within Lambda. So I have this endpoint that you can curl, and you can say it, and you can give it a URL, and it'll build an MP3 of reading the entire article in that URL. That's also open source. You can look at it, and it's all in Python. Any other questions? Yes.
Does the deployment workflow look like, or
Yeah, the deployment workflow is done best through something called code build or code star. But I don't use that because I'm a nerd, and I sit there on the command line and I just manually upload stuff. But what you can do with code build is you can say, hey, I have a Lambda function that I want to deploy, and it'll build you a repo, it'll build you a pipeline, it'll build you a testing framework and all this other stuff, and you don't really pay for any of it unless you use it a hell of a lot. And CloudFormation is the primary way that I deploy. If you're trying to deploy on other platforms, there are a lot of other really good ways of deploying functions as a service. I think the SAM model is super powerful right now, so that's one of the best ways of deploying. The next question typically after deployment is monitoring, so I'll preempt that and say the best way to monitor your distributed applications and microservices is using a service called X-Ray. X-Ray looks really cool. It builds this pretty service map, and it's super cheap, which is not a problem that I worry about working for AWS anymore. So you can see the last few things that we did, and we can see the initialization time, and we can see what was happening, it ran for 200 milliseconds, blah, 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 blah. Any other questions?
do you have any suggestion regarding the data that cannot be stateless, like when to set the cache, or
Data that cannot be stateless. I recommend, I frequently have connection pooling to either Postgres or DynamoDB. So DynamoDB doesn't need connection pooling, but for Postgres you do need connection pooling. So there's an Nginx Postgres reverse proxy that you can use, and you can talk to the database through your Lambda functions that way, and you get a lot done. And I think we're probably super out of time. So,
Yeah,
thank you guys very much.
Thank
I
you
really
very
appreciate
much.
it.